All right, geometry 11.4, volumes of prisms and cylinders. So we're going to take a look at these three-dimensional shapes and finding volume. And again, in your geometry class, they're very focused on the circular objects, so cylinders in this situation, but we should start with prisms. So again, here is what a prism is. A prism is a polyhedron. It has two congruent parallel faces called bases. Two congruent bases. The other faces are called the lateral faces. And again, remember, when it comes to prism, your lateral faces are going to be rectangles. So those guys will be rectangles. Now, it's very important that once you identify your bases, you also identify your height. Your height of your prism is the length of the altitude connecting the two bases, right? Perpendicularly connecting the two bases. But that's the height going between the two bases. So in these pictures, these edges would be considered the heights. So for a cylinder, again, a cylinder is just a prism with circular bases. Again, we don't consider it necessarily a polyhedron because it has circular shapes involved. Okay. Volume is the space that a figure occupies. It's in cubic units, right? So volume is a space that you occupy. Its units are cubic units. So be aware of that when you're doing your delta math, that you input it in cubic units. So this idea of this Cavaliere's principle, and again, I always think of it as the Cleveland Cavaliere's principle, right? Ha ha ha. So it's trying to introduce you to volume. So you have three 3D figures down here. You have a square prism. This is almost like a rhombus prism, because it's angled. And then you have a triangular prism. So what this says is that if two figures have the same height and the same cross-sectional area at every level, so cross-sectional area, including at the bases, then they will have the same volume. So in this figure here, what they're saying is that each cross-section has an area of 6. So this square has an area of 6. This, again, I guess it could be a rhombus, I suppose, or a parallelogram has an area of 6, and this triangle has an area of 6. And again, because they're all the same height, as you can see, all of these figures will have the same volume, despite being different shape. Okay, be aware of that. Okay, so from this we get our volume formula. So to find the volume of a prism, you are going to take the area of the base and multiply it by the height. This capital B does not stand for base like in area formulas. This stands for the area of the base. So if your base is a rectangle, then your capital B will be the base and height of that rectangle. If it's a triangle, then that capital B be 1/2 base times height. And if it's a circle, that B will equal pi r squared. And here comes your volume formula down there for a cylinder, right? Pi r squared h. So again, this capital B is not a one dimension. This capital B is a 2-dimension. It's an area. The height that goes between the bases is what gives you that 3 dimensions for that third unit. And again, your volume is units cubed. That's how it's measured. All right, so we're going to go into Delta Math and do some simpler volume problems, and then go to Edge Elastic where I have some more creative word problems. Okay, this first one, I just want to walk you through. This is going after the definition of volume. So it says, answer all the questions below to determine the volume of the rectangular prism. So it says, press the play button. So I will. Notice it's filling up, right? It is filling up with how many of the cubes? Well, it's going along this 6 edge. So there's 1, 2, 3, 4, 5, 6 cubes. Now it says, press the play button again. And now notice it's going along the 10 at the bottom. So again, there are now going to be 10 rows of 6 cubes. 10 rows, sorry, 10 rows of 6 cubes, or 60. Not, that's a 60, sorry. 60. And what that does to me is that represents the area of the base of this rectangular prism. 6 by 10 is 60. And now the third play is now we're going to take those 60 squares and we're going to do a height of 3. So we're going to make 3 levels of those. So now we're going to take the 60 and multiply by 3 to get 100 and, geez, sorry, this is delta math lag sometimes. 180 cubes. I said squares, cubes. And there we go. And that's the volume there. And again, what is your formula for the volume of a rectangular prism? Again, you would just take length times width times height, right? The 3 dimensions multiplied together, and you would get 180. Green check mark. Oh, yeah. All right, next problem coming. All right, let's take a look at this problem here. It says 2 containers designed to hold water are side by side, both in the shape of a cylinder. Container A has diameter of 12 feet and height of 20 feet. Container B has a diameter of 16 feet and height of 12 feet. Container A is full of water, and the water is pumped into container B until container A is empty. After the pumping is complete, what is the volume of the empty portion of container B to the nearest tenth of a cubic foot? So let's see once I hit play what happens. Wow. Look at that. Whoa. So now you see, look. So what this idea is that the amount of water and volume or in container A is not enough to fill container B. Container B must be a little bit bigger or be able to contain a little bit more water than container A. So the idea is it's a subtraction. Find the volume of A, find the volume of B, and subtract them to see what the empty portion of container B is. So I will try to do this without using my calculator until the very end. So let's go with container A. It is a cylinder. So the volume is equal to the area of the base times the height, but of course the base is a circle, pi r squared. They told us the diameter is 12. That means the radius is half of 12, and half of 12 is 6. So we're looking at pi times 6 squared times, and the height is 20. So that'll be the volume of A. And then B's volume, same formula, pi. Now its diameter is 16, so its radius is half of 16. Half of 16 is 8, times 8 squared, and its height is 12, times 12. And again, it looks as though container B is bigger than container A. So we're going to take B minus A. We're going to take pi times 8 squared times 12 and subtract pi times 6 squared times 20. And that's exactly what I'm going to type in to my calculator. And it says round to the nearest tenth, so that's what we'll do. So again, I tried to use as very little rounding as possible if I'm able. All right, so let's go to the calculator now. I took a picture because I don't remember things very well. So pi for pi times 8 squared times 12 minus pi times 6 squared times 20. And there you go, 150.79. It said to the nearest tenth. That 9 does round the 7 up to an 8. 150.8, and that would be units cubed if we were keeping score doing edge elastic. 150.8 units cubed. Let's take a look. 150.8. Oh yeah, nice. Okay, I got one more problem coming. All right, so here's our next problem. It says 2 containers designed to hold water side by side, same, both in the shape of a cylinder. A has a radius of 13, height of 20. B has a radius of 16, height of 19. Container A is full of water, and the water is pumped into container B until the container is empty. To the nearest tenth, what percent of container B that is, what is the percent of container B that is full after the pumping? So let's watch. So it pumps out. I clicked play. It pumps out. It pumps out. It pumps out. And there we go. So now, in the previous problem, it was a subtraction. Well, now, when you're looking for a percentage, right? We're looking for the percent full. We're going to take the volume of A, which is the amount of water that makes it full, and we're going to divide by the volume of B, which is the amount of water that B could hold total. And we're going to times that by 100. And that will give you the percent that it is full. That it is full. Okay? So let's do it now. What's the volume of A? Well, again, it is a cylinder. Area of the base times the height. The base is, of course, a circle. Pi r squared h. Pi. So for A, the radius is 13 and the height is 20. Times 13 squared times 20. And for B, it is again pi r squared h. Pi times its radius is 16 and height is 19. 16 squared times 19. So we're going to type this in just like this. Pi times 13 squared times 20 divided by pi times 16 squared times 19 times 100. And to be honest, we can actually cross off the pi's to make our lives simpler. All right, so 13 squared times 20 divided by 16 squared times 19 times 100 will give us our percentage to the nearest tenth of a percent. So let's take a look here. All right, so we're going to do a fraction. So it said, I'll do 13 squared times 20. Notice I don't need the parentheses, really. 16 squared times 19, and that's all times 100. And there we go, 69.49. That 9 rounds the 4 up to a 5. So this is 69.5% full. 69.5. And if I look at my problem, right, that's about right. It looks about 2/3 full. So that seems about right. So I'm going to assume that they know it's in percentages. So 69.5 is my percent. Submit it, make sure. Good, green check mark. So they knew it was in percent. Okay, awesome. Cool, cool, cool. All right, so this is your Delta Math. Let's go on to Edge Elastic where we have a couple more trickier problems. So new video for the Edge Elastic.